Alright, hello again. We are continuing our lesson about the quadratic formula that we started in the previous video. And what we've done so far is I've shown you how to complete the square in order to derive the quadratic formula. Quadratic formula is one of those things that's so important that you ought to know where it came from. Just like you ought to know where Pythagorean theorem came from, or how to prove it, I should say. You should know how to derive the quadratic formula. We talked about that. And now what we're going to do is we're actually going to look at how you solve quadratic equations using the quadratic formula. Alright, now let's begin by revisiting what we just learned and what really is review for you, because you learned this in Algebra 1 and Algebra 2, probably used it in geometry at some point as well. If you have an equation ax squared plus bx plus c equals 0, then you can solve that using this formula right here called the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so that is the quadratic formula right there. Now there's some things that I need to discuss with you here, and one of those is this: that the only time the quadratic formula works is if you have an equation, a quadratic equation where it's set equal to 0. Now it can actually be used for other types of equations other than quadratic, believe it or not, but if you can write an equation in a quadratic form and you set it equal to 0, then you can find out what values of x make that equation true using this formula. Now a very important note: if you're reading this if you read about the formula in your textbook, it has a little blurb off to the side that says that since this formula is in your IB formula booklet, that you don't need to memorize it. And while I agree that when it comes to your IB exam, you're not going to have to know this because it will be given to you, I disagree with the perspective that you don't need to memorize it, because this is one of those things that's so important in math. You need to have it memorized if you don't already. And it's really pretty easy to memorize. Okay? Now, I can't believe I'm about to do this and then post it on the internet. But anyway, here I go. One of my good teacher friends taught his daughter, who was then 2, maybe 3 years old, the quadratic formula by using a popular American children's tune, Pop Goes the Weasel. Alright? And so, this is what I can't believe I'm about to do. I'm about to sing for you. This is how you can learn the quadratic formula if you don't already know it. It goes like this: x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You get that one time, folks. Hope you enjoyed it. Okay, anyway, learn this formula and learn how to use it even more importantly, and that's what we're getting ready to do right now. So I've made up several equations that we're going to solve using the quadratic formula, and what we're going to do is we're going to make sure that those equations are in that form: ax squared plus bx plus c equals 0. Then we'll apply the formula to be able to find the solutions for that equation. Okay, now I've written the quadratic formula up in the top right hand corner. My recommendation to you, if the song isn't enough to help you remember, write the formula down every time you solve a quadratic equation until you get to the point where you've got the formula memorized. Alright, then there's no point in writing it down every time. You can just actually go ahead and use it at that point. Alright, now we've got this equation already to where it's set equal to 0. Alright? And when you set a quadratic equation equal to 0, then you know what your a, b, and c are. A is just the coefficient for your quadratic term. B is the coefficient for your linear term. And then c is the constant term. Now I'm going to label those for this problem just to make sure we're clear about what a, b, and c are. So there are the values of a, b, and c. Just make sure you always use a sign that's directly in front of the term to determine whether a, b, or c are positive or negative and so forth. Alright, and once you know what your values of a, b, and c are, now we're going to substitute those into the quadratic formula. And you've used this enough times in your life that I'm going to maybe go ahead and simplify a little bit of the work for you, or at least do it as we go. Alright, the first thing we need to do is we need to use the opposite of b. And since b is negative 9, the opposite of b is going to be positive 9. Alright, and then plus or minus the square root All right, well, then the next thing is we've got to go ahead and use b squared. If you square negative 9, you're going to get 81, right? So let's just go ahead and write 81 there. That's our b squared. And then minus 4ac. Okay, so we're doing minus 4 times 6 times 2. And that's math we can do right now mentally. If we couldn't do it mentally, you could use your calculator to do it right now. 4 times 6 is 24. 24 times 2 is 48. So we're going to have minus 48. Alright, all over 2a. Alright, so 2 times our quadratic coefficient, that's going to be 2 times 6, so 12. Okay, now if you can go ahead and do some of the math mentally the way that I did, it makes this formula a lot less intimidating to use. Hopefully that all makes sense. The big thing that you got to pay attention to is whether or not this is actually an addition or subtraction sign. Now you're doing negative 4 times a times c. Well, negative 4 times 6 is 24. Negative 24 times 2 is negative 48. That's why it was negative. But sometimes that becomes a positive if either a or c is negative. Alright, well, we're going to continue simplifying our answer right now. We don't want to leave it that way. So let's go ahead and do the subtraction underneath the radical. 81 minus 48 is 33. Divided by 12. And then you always want to, if it's possible, simplify the radical and then simplify the fraction. Now it turns out we can't do either in this case, but I want to point out why. 33, its only factors are 11 and 3, and neither of those are perfect squares, so we can't simplify the radical. Alright? And then we can't simplify the fraction because these three terms, look at the coefficient, that's a 1 square root of 33. 9, 1, and 12 don't all have a common factor that we can divide from each of them. So this answer is as simple as we can get. This is what's called the exact value for the answer. Alright? Now, that means we do have two solutions here. One solution would be that x equals 9 plus the square root of 33 divided by 12. And another solution then is that x equals negative 9. Or sorry, not negative 9, but 9 minus the square root of 33 over 12. All right, and those are exact values right there. And IB always allows you to leave your answers as exact values unless you're told otherwise. So those are acceptable answers. Of course, they also always allow you to express your answers to 3 significant figures unless otherwise noted. So one of the things you can do is go ahead and use your calculator and figure out what is 9 plus the square root of 33 divided by 12 and what is 9 minus the square root of 33 divided by 12. Whoops, didn't mean to do that. Alright, we're back. And if you choose to do that and give approximate values instead of exact values, these are the values that you would get rounded to 3 significant figures. Alright, that's how you use quadratic formula. Let's try a couple more examples. Alright, so you see the equation we're trying to solve, and remember that in order to solve a quadratic equation, you need to have the equation set equal to 0. And so one of the things that I'll do here is I'll go ahead and bring everything over to the left side of the equation. That's typically where you'd put it. So let's make this negative 3x squared plus 10x plus 8 is equal to 0. And then one other thing, will you truly prefer for a to be a positive value rather than a negative value? So I'm going to divide everything by negative 1, and that's going to make this 3x squared minus 10x minus 8 is equal to 0. Okay, now we're ready to use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, the opposite of b, since b is negative 10, is going to be positive 10. Plus or minus square root. Okay, then our b is negative 10, right? And so if we square it, we're going to get 100. Alright, for the minus 4ac part, I want you to do negative 4 times a times c. Alright, negative 4 times 3 is negative 12. Negative 12 times negative 8 is positive 96. We're going to have a plus 96 right there. All over 2a, since a is 3, 2a would be equal to 6. Alright, and then let's simplify. We're going to get 10 plus or minus the square root of 196 over 6. And remember, I told you that you always want to try to simplify your answer, both the radical and the entire fraction if you're able to. And we will be able to simplify the radical in this case because there's a factor of 196 that's a perfect square. And actually, 196 itself is a perfect square. That's 16 squared. So, watch this. I'm going to clear the screen a little bit and just simplify the answer now. Okay, so that's going to become 10 plus or minus 16 over 6. And since we don't have a radical anymore, we don't really have any choice but to go ahead and just separate this into two problems and then simplify. Let's make this x plus equals 10 plus 16 divided by 6, and also x equals 10 minus 16 divided by 6. So we get 26 over 6, which is 13 thirds, and negative 6 over 6, which is negative 1. Okay, now you could write that 13 thirds as a decimal to 3 significant figures if you like, but those are the two exact values. Good so far? All right, we're going to try a slightly more difficult problem next. Come along with me, let's do it. I want to say slightly more difficult. This equation is nowhere close to being what you would typically think of something you could solve with the quadratic formula. All right? Right now it's a proportion. You can't even tell that there would be a quadratic equation. Still, if we're going to solve using the quadratic formula, we need to set this equation equal to 0. And since this is a proportion, what we're going to do is we're going to use cross multiplication to help us in the process of setting this equation equal to 0. So cross multiply here to begin. So we're going to multiply 2x minus 3 by 3x, and we're going to set that equal to the product of x plus 6 and x plus 1. Okay, now 2x minus 3 times 3x is going to be 6x squared minus 9x. Then x plus 6 times x plus 1 will give you x squared plus 7x plus 6. And we've almost got this ready to use a formula. Let's go ahead and set it equal to 0. So subtract x squared from both sides, you get 5x squared. Subtract 7x from both sides, you'll have negative 16x. And then subtract 6 from both sides, you'll have minus 6 is equal to 0. Now you're ready to use quadratic formula. You've seen me use it enough. Go ahead and try it on your own right now. See what you come up with. Alright, I hope you've gotten this far correctly. If not, go back and check your work and see if you can correct it, and then continue. Now, I've talked about a couple times how we want to simplify the radicals once we get to this stage, and then simplify the fraction if we can. And this is a radical that simplifies even though itself is not a perfect square. So what we're going to need to do is find a factor of 312 that is a perfect square, and it turns out that the only such factor is 4. Alright, and so I think because we talked about how to simplify radicals, you'll understand where I'm getting this next step from. We can simplify that to 16 plus or minus 2 square root of 78 over 10. Alright, then the next thing I need you to notice is this. We haven't had the chance to do this yet in this video. We can simplify this fraction even though we can't do anything else with the radical. And that's because all three of these terms, 16, the coefficient for the radical, 2, and the denominator, 10, all have a common factor. And that common factor is 2. And what we're going to do is we're going to divide each of those by 2. And so we're going to get 8 plus or minus 1 squared of 78 over 5. And that is 2 answers, right? So you don't have to separate them. You're welcome to. But you can leave your answer like that, and that gives me both exact solutions. Any questions? Not that you can ask me right now, but you can ask me in class tomorrow if you need to. All right, we're going to do one more problem that we could use the quadratic formula to solve, and then that's going to be it for this video. Make sure that you have understood how to use this formula. It's super important that you're able to do this because it works all the time. It's just a valuable tool for you. All right, word problem next. A rectangle has a perimeter of 38 millimeters and an area of 78 square millimeters. Sorry, I forgot to make that the units here all pretty, but that's supposed to be millimeters to the second power right there, square millimeters. We're going to use the perimeter and area of a rectangle to be able to find out what the length and the width of the rectangle are. And right now it's not nearly apparent to you why the quadratic formula is going to be involved, but it will be very soon. So let's go ahead and do this. It is a geometry problem, and you want to draw pictures with geometry problems every time. There's a rectangle, and we know that a rectangle has a length and a width, and we're trying to figure out what that length and width are. All right? And we're given two pieces of information about the rectangle to help us do that. We're told that the perimeter is 38, and that the area is 78. We'll go back and add in the units later on. Let's just work with the numbers for right now. Alright, here's what we need to do. We need to come up with equations then that relate the length and the width to those two quantities, perimeter and area. And I think you know that perimeter is equal to 2 lengths plus 2 widths. Alright, because you got 2 of each of them, and if you add those, if you double them and add them, that gives you the perimeter. So one equation we can make here is that 2 times the length plus 2 times the width has to be equal to 38 because the perimeter is 38. And then a second equation that we can make involves area, and you know you find the area of a rectangle by multiplying the length times the width. So we can say that length times width here is equal to 78. Now right now you still don't see any quadratics involved, but we're getting pretty close to that. You do see 2 equations relating the length and width, but don't those equations have 2 variables in them each? And we can't solve any single equation if it has more than one variable in it. Alright, essentially what we have here is a system of equations with 2 variables. And if you have 2 variables to solve for, you need 2 equations to be able to make that solution happen. And what we're going to do is we're going to use the substitution method for systems of equations to be able to find our solutions here. And here in particular is what I'm going to choose to do. I'm going to take this perimeter equation and I'm going to get either L or W by itself. I'm going to choose to get L by itself personally. And then whatever value I get for L, I'm going to substitute it into the area equation afterwards. So watch this. In that perimeter equation, I can say that 2L is equal to 38 minus 2W. And so L would be equal to 19 minus W, right? There we go. So L is equal to 19 minus W. That's important. Now what we're going to do is we're going to go to this area equation and we're going to replace L with 19 minus W. So that's going to look like this. 19 minus W times W is equal to 78. Are you seeing where the quadratic part of this problem is going to come from yet? Now this equation has only one variable in it, and we're going to have a W times a W, so it's going to end up being a quadratic equation. What I would like you to do right now is go ahead and pause the video and solve this quadratic equation. Now I am going to clean up the screen a little bit for when you come back, so if there's any information here that you don't understand, make sure you get it down now, and then I'm going to clear everything but the picture and this equation right here essentially. Alright, solve it. Alright, so here is the work. Alright, just pay careful attention, especially for how I got from this step to this step. I subtracted 78 from both sides, And then I divided everything by -1 so that I could have a positive w squared instead of a negative w squared. That's where that came from. And then you see the work. And then when I got to the end, all right, well, 361 minus 312 was 49. Square root of 49 was 7. And then 19 plus 7 is 26. Divided by 2 is 13. 19 minus 7 is 12. Divided by 2 is 6. The last thing we got to talk about is just something kind of interesting here. The width can't possibly be two different measurements, can it? All right. Now, our formula doesn't distinguish between the width and the length. What it did was it just went ahead and gave us both dimensions of this rectangle. We could say the width is either this 13 or that it's 6, but then the other value turns out to be the length. And if one of these values is actually the length and one of them is the width, we're going to say that the length is 13, the larger of the two numbers, and the width is 6. Alright, length equals 13 millimeters, and the width is 6 millimeters. And it's real easy to check. 2 times 13 plus 2 times 6 will give you 38. 13 times 6 is 78. This worked out perfectly. It's just an example of where a quadratic equation can be a very useful thing for a real type of problem. Alright, you ought to be proficient with the quadratic formula at this point. I will see you in class. Have fun.